So I've been working on Sprint 3 and I've got some questions.
Good.
First of all, the assignments. May I share the screen?
Please.
So I've been focusing on book A, geotech part of book A, and there are some entities I have to include. Do I need all these entities in one file?
Preferable,
What are you
yes, but
focusing on?
the checker is only going to complain that some entities were missing if it doesn't find
okay.
But it's also the question: what are you trying to produce? Are you looking at geoscience observation?
Yes. We are particularly interested in representing borehole and 3D geophysical survey data. So
In that case, you're gonna need borehole, you're gonna need site, you're gonna need project, you're gonna need many. You won't need spatial zone, probably, but you're gonna
spatial
need a
zone.
lot of the stuff from before.
I wasn't sure which I need to include because just to represent borehole and some in situ data, I don't need, for example, spatial zone or, well,
That's
I
why
can
I
include,
said
but
you don't need that.
yeah, also mapped feature and stuff like that.
Yeah, you're probably not going to need that. Of course, you're going to need the geoscience, but from the previous sprints, from 1.1 onwards, you're going to need the context of your project. You're going to need
That's right.
everything from project, and onwards. But for your particular test, you're not going to need anything other than what you want to include.
That's what I meant. So this is the file I've been working on. I've got project and owner history, application site, and stuff like that, and geographic reference. And the borehole starts from here. IOC borehole. That is also the borehole properties, and so on.
Yep, that should be fine then. But it has to be somewhere in the. It has to be navigable from IFC project, so you have to connect it to IFC project somehow through IFC site, probably.
Yeah,
actually, I just saw that, Kazunori. If you can go to the line that defines the borehole.
Yeah.
The next line. So the entity 36. This one should be
aggregates, but
this one should be well contained in spatial structure.
Oh, okay.
So I think the 24 there, that was the IFC site, if I've seen correctly.
If 24 is site, yes. Then
yes. Yeah, the 24 is site, yeah, so correctly. And the boreholes is an IFC element, I believe, even. So you should be using IFC well contained in spatial structure to connect those two.
Yeah.
But that answers the what Sergey has said, that it should be navigable from the project. So site is in project, borehole is in site, so thus you can get from one to another. And I saw another error that I just want to.
Yeah.
make you aware of. I think it was number 9.
Number 9. That's pretty.
You were quick, Stefan.
It's a kilogram, not a kilogram.
Yeah.
Oh, okay, yeah.
Yeah. It's a small error. I think the checker would have complained here, but as I see it, I can just tell you.
That's quite Japanese
Here
mistake, I think.
probably already the serializer would complain.
So with this actually I could represent the borehole like this. I just used beam vision.
Yeah.
And all these properties are there. Well, I think beam vision doesn't really understand the layer assigned to product. I think.
It
That might be
might.
Yes.
You can go to objects to the second tab. I mean to the second ribbon next to view.
Oh, this one.
Yes, and if you click on structure here, maybe you can select a different structure. So yeah. No, this is not going to be
No.
it. Then try
No.
groups. Maybe in
Oops.
groups the assignments
No.
are
No, I don't think so. And
If I use a layer assigned to, then it doesn't show up. So
yeah, I think beam vision lacks some things, and some things it sort of doesn't care. Like you saw you had sort of the correct structure here in beam vision, even though you had rel aggregates instead of contained in spatial structure, for example. So it sometimes it's a little bit sloppy, and sometimes it doesn't sort of understand. So which is a pity.
It's not that strict. Yeah, it's
No.
very forgiving, so to say.
Yes.
Not that strict. Some things it just pushes through, and some things it doesn't understand. So
Yeah.
you never know what you're getting, because like Lars said, some things it just interprets as it sees fit, and some things it just ignores, or I haven't actually seen an error. Lars, can you remember seeing an error from BIM Vision?
Yeah, well, error, if you include an alignment, I think you will actually get a message, I don't understand this.
Really?
Sort of.
Maybe
But in principle,
we could ask.
It pushes through. It just goes through everything, and what it doesn't understand, it ignores.
But I would say, I mean, if we, for example, if it doesn't understand the assignments, like you assign the observations to the borehole, for example, it will not understand that, for example. But I mean, I think that the checker, when you push to GitHub, it will sort of report on that. If you don't have that.
Okay.
So yeah, but also one thing that I would like to say, if you, I mean, as an expert in this field, if you feel also like you would like to add something to your test case, then I would say do so, because I mean.
Like what?
I mean, for example, if we don't have specified the entities that you find particularly interesting in our test case, I would say that I mean, it's always good to have real test cases with.
That's one thing I also wanted to ask. I summarized my problem issues. So if I understood right, IFC borehole is attached to the whole borehole, the whole length.
Yeah.
And that has the pset borehole common. Is that
Yes.
correct understanding?
Yeah.
Okay. And then IFC geoscience observation with the borehole log type. Is this attached to a borehole, the whole borehole, or the section of the borehole?
It's attached to the whole borehole as of
Whole
now.
borehole.
Yes.
Okay.
Yes. Yes.
So
through product assignment.
Well, in that case,
but we also, I should say, we had this discussion before Christmas, and I will look up the conversations again, because we had this discussion with Artemis. If you remember, Michel, and maybe Sergey was there as well, where we had this discussion because we were discussing book A and book B, and they had this sort of, I would say, representation in between, where you actually represent the different sort of interpreted layers, but per borehole. And we sort of proposed a representation for that as well, like these, like you have here, these sort of different parts of the borehole. And I will look that up. If you were not in that discussion, I will make sure that you get it as well.
So if the geoscience observation is attached to a whole borehole, then this pset geoobs borehole geolog interval is only for one section, each section. That means we have, I think, this way. On the right-hand side, we have only one geoscience observation borehole log for one borehole, and we have multiple psets for different sections. Is this
that could be one way, but I will look up also this other representation. But
probably makes sense to assemble them, wouldn't it, and aggregate them, and then each individual one would have its own pset. Otherwise, it's a bit difficult to interpret what's what. But I do remember that having this discussion. I just don't remember the outcome.
Yeah, I don't remember the outcome either right now, but there is this conversation.
Yeah, the discussion had to do with the fact that they are commenting upon the raw data before it is. So to have raw data, they have comments that sort of refine a bit the raw data, and once that is done, then it is used for interpretation purposes. So the idea is that there is a sort of a middle step where they do some level of interpretation, but that's directly on the raw data to refine what is used then for interpretation. That was mainly what we discussed.
But if this geoscience observation is attached to a whole borehole, then each pset doesn't have depth range. It doesn't have property that indicates which section that property is extracted. So
that I'm sure we discussed as well.
Yes. So
but it would make sense to assemble this, to aggregate it, right? Because then you have, you know, your own individual ID for each of the sections or segments, and you have properties on them.
Yeah,
That's sort of the way you would probably have to, or not have to. You can do it in many ways, but it would be the cleanest and
what do you mean by
most.
aggregate? So there are several sections, and then aggregate as one borehole, and then attach geoscience observation.
So you would have a geoscience observation on the entire one, the entire borehole, and then you would decompose this one geoscience observation into many. How decomposition works in IFC is that the whole, so the one for the entire borehole, is made up of the sum of parts. So the top one doesn't have any geometry, and it only has whatever is on the entire thing. But the parts make up the geometry, and the parts make up also the semantic data. So in principle, you could go from borehole to the entire geoscience observation, which would be decomposed into many geoscience observations.
Yeah, that sounds good. But well, actually, the next question might be relevant for that way. We might have several tests, for example, test A and test B. And test A and test B are not necessarily for the same section. For test A, it's this section, but test B, it's, for example, longer or shorter. Can that way handle this case?
I would just then have a different geoscience observation for test A and another one for test B with two different compositions.
Yeah.
And both of them assigned to the borehole. I mean, it's sort of why we actually instantiated, or let's say have had this discussion, because at the start we weren't even thinking of having observations as individual objects inside an IFC file, just property sets. But this is the perfect example why we actually did the right thing in creating a geoscience observation as an IFC element, because then we can of course assign them to a physical entity, a borehole, and do the same sort of IFC mechanics that IFC allows. We can assign them, we can decompose them, we can reference documents on them, we can put properties on them. So I think this is the perfect, you know, if building smart says geoscience observation, that's not an element. We just show them this, and it's done for, I think.
Yeah. Yeah, and I see this is actually a little bit of a different case than we discussed with Artemis and Jan Erik. So, but I mean, in this case, just to clarify, Sergey, then the geoscience observation in this case, they would actually have their own representation, which is sort of the part which they actually represent, and you could aggregate if you like. Okay.
It's not.
No, it's not necessary. No, it's not mandatory. So yeah. So in this case, each of the tests, whether it's test A or test B, would be their own sort of instances. I can just show you what we discussed with Artemis as well, if I just share shortly. I found the...
Yeah, so two instances both assigned to the same borehole.
Yeah.
Geoscience observation.
Yeah. So we in the case where we discussed with Artemis, we instead had this case where you have the borehole. Their sort of process of working was that they have the borehole with the borehole logs and observations and data connected to the boreholes, and then they do sort of a first interpretation of that. So they have sort of they interpret where they have sort of different materials, but in that case I sort of understand it as sort of they interpret like this section of the borehole has this sort of homogeneous material, and this section has another material like clay or soil or rock or whatever. Right. And then from there, they sort of create this sort of real interpretation of the whole sort of 3D surface or layer in the terrain. So it's sort of a 3-step. They have the borehole, and then they make their interpretations in the boreholes, and then from that representation, they derive sort of a, for example, a triangulated surface. So in that case, it's sort of a similar thing that we proposed. So in that case, you actually have, for each borehole, you have geoscience features, which sort of represent the homogeneous part of a borehole, which you can also assign to the borehole, of course, in that case. So
this is sort of another view on a similar thing, because first of all, the geoscience guys probably have to do these tests, right? And
yes.
And then you can interpret the data, right? And then you get to the possibility of triangulating.
Yeah. And because we have also had this discussion with the geoscience team, because I also have an image here of sort of the old geotechnics model in 4.3, where you have this geotechnical stratum entity, and an IFC borehole is in that case an geotechnical assembly. So you have a borehole is actually an assembly of strata, but our domain team didn't like that model at all, because they wanted more, and you were supposedly in it, wanted a more sort of topical breakdown for geoscience, like you have these geotechnical units and geological units and hydrogeo units and so on. So then we came up with this as sort of a solution for that. So you have the geoscience model, and you have then features, which could be either boreholes, but it could also be used for the whole sort of 3D strata in the terrain.
But Kazunori's request goes a little bit further than that, in the sense that it decomposed clearly the different sections.
Yeah,
but
so
it's
another, the principles are the same, yes.
As you see, Michel, there is no way around an MVD.
No, I completely agree with that. This, I mean, your slides, Kazunori, is I would say a typical input for usages that needs to be specified. So it's
what is the final recommendation we place to Kazunori then in that particular case? Is that this idea of a grouping, as you said earlier, on your slide number 3?
At least having each observation as a separate instance in this case, but assign it to the borehole.
stuff like this,
Yeah,
we would
so
really need to address separately after we have the main specification done, because when we publish to ISO, it makes sense that all of these templates for assigning stuff are already in place, because then, of course, once you have the ISO set with general usage, you can easily just say, you know, I'm referencing an official ISO standard, and this is my instantiation of the ISO standard, and that makes for a model view definition. I don't want to discuss risks here, but this would be the best way to do it.
Could I just ask then a detailed question here? I don't remember in this case depth range. Is that two values, or is it
yeah.
what is it? I don't remember. Yeah. So you actually
values.
know. Yeah.
It is bounded, isn't it?
Yeah, so you actually know, you can say that sort of give it two depths, where it starts and where it ends.
That's correct.
Right?
Yeah.
Yeah. Okay. Yeah. Then we are
Which
fine.
property set was this? This was GeoOps.
Sorry.
Geolog interval. You see the name there.
GeoOps geolog.
Sure. Geolog interval. Is that?
I think it's already. I think.
No, it's GeoOp borehole. That one might be merged already.
I think it's merged. Because we only included in our sprint specification p-sets that were already merged. GeoOps borehole, yeah. No, yeah.
It's the one here.
So we don't have a depth range in here.
No.
I think yeah. That's why I wanted to check, because I think we settled on a geometric representation might even be for, and that's what I wanted to check, because I'm not certain what we actually did with this GeoOps.
But the way you said about decomposing the geoscience observation, that is based on what it decomposes.
But do you actually need to decompose even if all observations are, if the observations are assigned to the same borehole, you sort of have implicitly the aggregation there as well.
So for example, in this case, what I'm missing is depth range, only depth range. So the simple solution I thought is that to add one additional property that is depth range in the p set.
Yeah,
but
and which totally would be needed if you don't have a geometric representation for the observation.
I think a geometric representation in the form of a polyline would be much more easier to understand here.
Polyline?
Yeah, it's just 2 points. Then, you know, you have a first point and a second point, and gets interpreted quite easily with the length and with a placement relative to the borehole.
I'm not quite sure, but someone might want to represent the borehole diameter. We use different diameter for different purpose. Could be thin, could be really fat. So
but I mean, the borehole has its representation.
Exactly,
which,
that would be a representation of the borehole itself, not of the geoscience observation itself.
Oh, okay.
Yeah.
So the geoscience observation could be a simple polyline. So if you drag, you know, for example, the geoscience observation and dissect the borehole into segments, if you reference the same start and end point and so on, you pretty much have that initial borehole representation and if the placements are of course also referenced, then you have a parametric thing. So if you drag something, you don't have to go and change the depth range of the property separately. I think that would be a more streamlined way of doing it. It's a bit more complex, but for the user in the end, it's much less complex because software has to do the logic behind it.
So in that case, just to summarize then, for this particular case, what would be needed is actually one borehole with its representation, right? Like a cylinder or something. And then you would have for each sort of segment here, observation, you would have a separate geoscience observation, which is assigned to the borehole. And the observation would then have this polyline as a representation, which sort of represents which actual segment it is then. But would you actually, Sergey, a question for you, would you actually need to aggregate the observations?
Probably
and why?
even that,
no,
unless you want, if you go to the next slide, Kazunori.
Yeah, so you were saying like this, just a line, yeah?
Yeah.
So if you go to the next slide here, you know, you have a geoscience observation test A and a geoscience observation test B. In that case, I would say it makes sense to aggregate them, but it's not necessary because then you have, you know, an aggregation or a composition of things that you can just go and pick test A and get all of your observations and test B and get all of your observations.
But again, that's different case though. I think we are still not 100% clear on the case we only have like test A observations that we'd like to aggregate. Right, Lars, the question was around that. How do we do the aggregation?
Yeah, but I mean, the aggregation sort of becomes implicit since the observations are assigned to a single borehole. So you sort of get a kind of grouping there anyway. You can easily find then all observations which is attached, assigned to the yeah.
But if you have test A and test B, it's not implicit what's together, you know.
No,
that is different.
That is different. So if you want to sort of easily separate the blue ones from the orange ones here, then maybe an aggregation would make sense. So you have a test B with all the orange ones and a test A with all the blue ones.
Yes.
Just makes for, I mean, it's sort of a question of the requirement, as always. If you want to have them aggregated, even if it's only one test, because you know maybe you have properties that you don't want to proliferate through all of them, and they are all for this one test. If you want some test metadata, then it makes sense to do it. Otherwise, it doesn't. And it's also a question of implementation. Do you always have this aggregation, or and then it's always the same? how to interpret stuff, or you have two different usages, and one is for many tests and the other is for only one test.
But the
It's a
different
question of
tests
requirements.
in that situation, Kazunori, the different tests would be clearly identified with a I don't know, a name or an ID or something, right? So at the end,
Yes.
you'll have a different set of instances of type B observations and a different set of instances of test A observations. And if you associate all these to one single borehole, then you'll still be able to find out, as Lars said, that it would be implicitly linked, of course, and then you can filter everything that relates to an ID test A and everything that relates to an ID test B.
Right. Yeah, that sounds much simpler than aggregate, but if aggregating all these sections or segments
To one
have
single borehole.
have some benefit, then it's okay. I don't really see the difference.
I
mean,
to
it's interpret
just
data.
It's just in this case, if you I mean, you are actually calling these test A and test B. So all the blue ones are test A, and all the orange ones are test B. So if you want to sort of have a clear representation of what is test A and what is test B in a data set, then it would make a lot of sense to aggregate all the orange ones into one instance, which clearly then represents test B, and another one that clearly represents test A.
So like aggregate like this.
Well,
the two options are possible, right? What you are saying, both Lars and Sergey.
It's not like aggregation or ID. ID is if you have an aggregation, then you have a top geoscience observation which gets an ID, and you can get all of your parts of the observation from that ID, because it's decomposed further down. So it's not either or. It's if you do aggregation, then you have an ID. If you don't do an aggregation, you have a list of individuals.
Yeah. So just to be clear here, it's not the p sets that are aggregated. You would need one one observation then for each interval. Like you have
like,
sort of
to the left. I think the best representation is on the A side.
Yeah.
Not that one slide. No, flip back one slide, please, Kazunori. Just so we are clear on this. Yes. So on this, I think we are recommending the A side, right?
Yes. Yes.
Okay.
And you
aggregate this like.
Yes.
Yep.
Or like this.
Yes.
Yes.
Okay.
Yeah.
And then assign to one borehole, because at the end, I think that what you really not want to do is to have duplications of the borehole itself, because you have one borehole, right? So you don't want to multiply the boreholes. You want to assign different observations to the same borehole.
Okay.
Different test observations.
Yeah. Okay. Then I'm gonna test this way.
Yeah. And then I mean, you have because we have a similar discussion in other places as well. This with geometry versus properties. like having the, in this case, having the polyline representation of the observation or the depth range. And I mean, that is sort of a separate, but right now we don't have the depth range. So you
have to
using
geometry, yes.
you have to use the geometry.
Yeah.
Yeah.
Okay. Yeah, I'm gonna try this way then.
Yeah. This it will be. I'm looking forward to this example.
Wish me luck.
Yeah. Good luck.
And I also made a voxel example.
Okay.
Like this. Well, actually, each voxel grid has a value, but they are not shown in the ILC viewer. But it's yeah, like this. So I can upload these two files. Sorry.
Is that the viewer from Peter Bonsma, or? And yeah, and it actually shows the voxel grid. That was nice.
Yes.
But yeah. Okay.
But
interesting.
Actually, each voxel grid, I assigned each voxel grid a value like this.
Yeah.
But these are not shown.
Yeah.
How would
So
you?
it shows the geometry, but not the values.
Sorry?
It shows the geometry, but not the values.
Shown?
That's correct, yeah.
So just instead of the cubes, you would like values.
Like colors or
I would imagine
colors.
Well,
that's different concept. Then you need to provide the information on how you would like to show the colors, and that's why we sort of stuck to the geometric representation of voxels, because colors can be assigned through representation and not through properties.
Well, yeah, color is just a visualization of the data. So I don't personally care, because color doesn't have meaning.
Yeah.
We just need to see how it's distributed and so on.
Yep.
So
that information has to be provided.
I think
you can do that. You can do that in IFC through the representation concepts, which allows you to apply colors to items, and that's why we insisted with building smart that it has to be a representation item, not the property, the voxel.
But I personally think that how you color those values can be up to the software.
Sure, but someone has to define it, Someone has to define it, what the colors are. So if there is no information on how to color it, then who is the authority on?
Now I think his internet connection disappeared.
The authority can be the receiving software, because the one who would be sort of using and interpreting the data would come from there.
I kind of agree with you, Kasanori. It could be some setting configuration in the software, but anyway, one thing
just
also in
to
here.
Finalize on my because it threw me out. Sorry, Lars. Because IFC is an exchange format and it's supposed to be a broad format, it's supposed to be generic. Peter Bonsma's viewer, of course, is not is not a voxel or let's say geoscience visualization software. So he needs the information on how to color stuff because he doesn't know. He's not a professional software for geoscience. Of course, geoscience software might have that feature, but for a generic viewer to also show it, you have to provide the information.
That can be a sort of a default set of color values.
Well, that's a question of an MVD because IFC is like I said, again, it's a generic data model that allows you to represent concepts, but you have to do it in order for them to show up. So if you just have values, nobody knows how you want those values to be represented. That's why IFC has all of this resource layer stuff that's supposed to serve the exchange format in terms of how to get things represented, how to get things. What else is in the resource layer? There's a lot of stuff there.
Kazunori, just to make sure I got that right, besides not being represented, the values that you transmitted, are they accessible when you sort of click the voxel?
That's a good question. I would also like to see
not
that.
each voxel. And I'm not quite sure I can read the values. Probably not.
Okay.
Maybe we can.
We'll chase Peter.
Peter Bonsma, yeah, and I mean you also have this option of
linking to external files.
Yeah, and also I was thinking of this. I mean, stating whether a voxel is actually what we call it a field or not. I mean, if it's a void or if it's actually something. I mean, that is also. I mean, you could actually describe a real geometric shape with voxels, right? By stating that these voxels are just void. Right.
Can you click on voxel data for a second? You do have values there, you see, but it's 3 question marks because the values apparently are a long list.
Oh, okay.
And
yeah,
he's not putting the list into there because you wouldn't have any information on it. But you know, he could build in a feature that when you hover over a voxel gives you the values or something like that. Here, if you have like 1 million voxels and you would have a list of a million values in real voxel data values, you know, who can do something with that? That would be
right. Well, for example, if I change the first voxel grid as a false, then it loses one voxel.
Okay, it does.
Yeah. So I think I've tried before.
Maybe you have to close it first.
Perhaps
Maybe
you
it
need to
doesn't
reload the
reload
file,
if it's the same name.
Yeah. No.
Yeah.
There it is.
There.
Yep. Ah, nice. I actually need to leave. I have another meeting in 1 minute.
we should be adjourning. Yes, indeed.
But
Great.
Thank you, Kazunori.
Yes, thank you so much. You've been extremely busy, obviously, during the Christmas break.
Well, I have a fun time during New Year and Christmas.
So hope we've provided you with a clarification. And yeah, please submit this to the checker as soon as you.
So I can submit all these 2 files separately to the GitHub. Is that all right?
Yep.
You can do them separately. You can do them in the same pull request, however you see fit.
Yep.
Okay.
Good. Excellent.
Okay.
Thank you very much, everyone. You
Thank
have a good
you.
day.
Have a nice day.
Cheers.
Bye.
Nice
Bye-bye.
day. Bye-bye.
Bye.